Hello everyone, this is Erlin from the Experience Research Lab. Today I'll show you how to run Poisson regression in RStudio. Poisson regression is a generalized linear model of regression analysis specifically used to predict count data. The dependent variable, therefore, is numerical and it must be count or whole number, not fractions or negatives. Some of the examples of count data are number of births, number of children, number of students who failed the final exam, number of hires leaving the company within the first year, number of customers unsubscribing from current services, and the number of traffic incidents that lead to death. Poisson regression is most suitable to predict count data with a low mean close to zero. The reason is that the higher the average value, the more likely it is to have normally distributed data. In such a case, multilinear regression is more suitable. On the other side, Poisson regression requires independent variables. It can be one or more nominal, ordinal, or scale predictors. Last but not least is that the conditional mean of the count data must equal the conditional variance. If you want to learn more about Poisson regression, please watch the previous video here. By the way, in this video, the dependent variable is the number of incidents that cause ship damages. Meanwhile, the independent variables are types of ships, year of construction, and period of operation. With Poisson regression, I'm trying to build a model that can help me determine which type of ship is more prone to damage. And to do this, I need to install at least 2 packages. So the required packages are Sandwich, that's the first packages. And the second one is Amazon. Select these two and click run. In addition to these 2 packages, I also need to load several libraries. They are library heaven. So I'll just first type in here required libraries. First one is library heaven. Which is to import dataset from SPSS. Second one is library tidyr, which is to filter data. I'm not really sure if I really need this or not, but just filter data. And the third one is library sandwich, which package I have just installed, which is to obtain the robust standard error and calculated p-values. The fourth one is library MSM, which I've just installed as well, which is to compute the standard error for the incident rate ratios. The last one is the library ggplot. I'll go with the ggplot to visualize the data. Now I select all these 5 and click run. With these 2 packages and 5 libraries, I am ready to import data from SPSS and save it as, let's say, ships. So I'll just write the code here. Get data from SPSS and save as ships. This is the name of the file or data set. So ships read save file, which is located in C folder. Program files. I could have copied and pasted the location, and just type it manually. Statistics, samples, English, and the file name is SPSS. Okay, great. Just click run now. So here, as shown in the global environment, I have a new data set listed with 40 observations and 6 variables. And if I click on this, I can see there are 6 variables. The first one is type for ship type, construction for the year of construction, operation for the period of operation, month service for the aggregate month of service, log month service for the logarithm of aggregate months of service, and damage incident for the number of damage incidents. At a glance, I can see that the last 2 variables here, log month service and damage incidents, have missing values. And since Poisson regression cannot work with missing values, I need to handle them first. But before that, I will print the descriptive summary. Perhaps there are more missing values in other columns. And to do that, I'll just type print summary by typing summary ships. Click run. It turns out here that only the last 2 variables, log month service and damage incidents, have missing values, and each of them has 6. When it comes to missing values, the most recommended solution is to remove them. To be safe, I'll duplicate the dataset and save the new one as SPSS1. So what I'll do is duplicate data by save it as SPSS1. We just duplicate it from dataset SPSS. Run. Now as shown here, I have another dataset in the global environment, SPSS1, with 40 observations and 6 variables. Now I'll update the duplicated data by removing the rows with missing values. So remove missing values from duplicated data. And save it still as SPSS1. SPSS1 pipe drop the NF values. Great. Click run. Now as you can see here, SPSS1 is now updated. It used to have 40 observations and 6 variables, but now it only has 34 observations left. If I click on this, I no longer see the missing values here on the last 2 columns, log month service and damage incidents. But to ensure, I can print the summary of the duplicated data by typing summary SPSS1. Run. As you can see here, the average value of the year of construction slightly decreases from 67.5 to 66.62. Meanwhile, the mean of operation increases from 67.5 to 68.38. Likewise, the mean of month service also increases from 4,089.3 to 4,811. However, the descriptive summary of the last 2 columns, log month service and damage incidents, remain the same. Particularly about the damage incidents, the range remains between 0 and 58. But there's something interesting here on this damage incident, which is the dependent variable on our analysis today, is that with a median of 4 and mean of 10.47, I would expect that the graph or curve will be right skewed, and this is an indication of a Poisson distribution. But there are 2 red flags here. The first one is that the 0 values, and too many of these, may lead to 0 inflated Poisson. And the second red flag is that the mean, which is pretty high and even higher than 10, which indicates that the distribution might be normal. But this is not confirmed yet. So what I want to do next is to see the descriptive summary, the mean of each ship type. So display descriptive summary by ship type with the dataset is ships 1. To apply damage incidence, this is the dependent variable of the response, and then type function x. And standard deviation x. Great. Just select these codes and click run. Now looking at the descriptive summary across ship types, I can see that the mean and standard deviation vary significantly, but the most obvious one is the ship type 2, of which mean is significantly higher than the total mean. It is 36.14 compared to 10.47, so it's almost triple the total mean. Looking at such a significantly higher mean compared to the other 4, I would expect that ship type 2 would have significantly different behavior